This is Mr. Gillum, and today we're going to use proportions to solve our word problems. And the word problems that we're going to solve are the same word problems that we did when we were talking about rates and unit rate. If you remember, the rate is just a comparison of two different quantities, and a unit rate is how much of something per one of another. So we talked about miles per 1 hour, or milliliters per 1 gallon, things like that. But today we're actually going to use proportions to make our comparison and solve our proportions as equations and find the unknown. So the same problem that we did with rates before, we're now going to use proportions to solve. Okay, and it does specifically say to use a proportion when solving, and so that's what we're going to do. It says we paid $40 for 8 hamburgers, which is a rate of dollars per hamburger. Okay, so I like to go right to my unknown first. Dollars per hamburger. So I'm going to put, we don't know how many dollars, X per hamburger, per one hamburger. And you might even want to write a little H in parentheses down there to remind you what you're talking about. Dollars per hamburger is equal to 40 for 8 hamburgers. Hey, looky there, we have a proportion. Okay, this all goes under the assumption that each hamburger costs the same amount, of course, but I'm just making a comparison using an equal sign. And this is basically the same thing that we did before. Now when I have a proportion, I can cross multiply and solve. And again, I want to emphasize that this proportion is an equation. This is not a multiplication sign. This is not a multiplication problem. All right, where we cross reduce and everything. No, this is with an equal sign. It's different. Okay, it means proportion. So this equal sign allows me to say, okay, well, if I cross multiply, I can solve. 8x equals 40, and I can solve for x. I know x must equal 5. So in this case, we're talking about dollars. So x equals $5, or you could say $5 per hamburger. Okay, so we're going to use proportions on what we were using rates for earlier. It says a pencil company used 60 grams of rubber to make 10 pencils. Okay, well, we can start with the 60 and the 10, or we can start with the unknown part. It doesn't matter. So let's just start with 60 grams over 10 pencils. Okay, and I'm just going to put over here grams over pencils, just so I remember. Okay. It says which is a rate of blank grams per pencil. So we don't know how many grams for every one pencil. Okay, so I'm setting up a proportion here. And again, I have an unknown and a proportion. I can cross multiply to help myself solve this equation. That's proportion. So in this case, we know that I'm running out of room here. 10x equals 60 when I cross multiply, like so. And if I solve my one-step equation here, I know that x would equal 6, or in other words, 6 grams per every pencil. Okay. The most important part in remembering when you set up your proportion is that you have the ratios the same on both sides. So if your first fraction is grams per pencil, and your second fraction also has to be grams per pencil. Okay. So in this case, it says an industrial machine is able to make 9 pens in 3 seconds. So let's do pens per second. Okay, so we have 9 pens in 3 seconds, and then over here we also have to have pens per second. Okay, when I'm setting up my proportion. What is the rate made per second? Okay, so when it says per second, we know it means per 1 second. So 1 down here, and we need to know what rate it is. So now I have this proportion that I can solve. And so when I cross multiply, just like that, 9 equals 3x, or x equals 3. So I know that. What is the rate made per second? 3 per second. Okay. So it's cross multiplication after I use my proportion. And again, we have some of the more challenging ones as well. Coming up, it says, in this case, it says took a pet store 10 weeks to sell 80 cats. So we're going to do weeks to cat. And really, when you use a proportion, it doesn't matter which way you set up the ratio, as long as it's the same on both sides of the proportion. So we're going to do weeks per cat this time. In this case, we have 10 for 80, and we need to know what is the rate sold per 1 week. And so we know that the weeks is going to be 1, and we don't know how many cats will be sold. Okay, so I set my proportion up. I just chose the first two numbers I saw and made a ratio, and then I determined what I do know in 1 week, and what I don't know is the rate of cats. So I'm going to go ahead and cross multiply. 10x must equal 80, and I can solve it. X must equal 8. So in this case, 8 cats per week. It's kind of an odd problem. All right, so 8 cats per week. Again, when I look at this next problem, it says for every 4 miles Vanessa jogged, Cody jogged 3 miles. If Vanessa jogs 1 mile, how far will Cody have jogged? Okay, well, I'm going to just go ahead and set my ratio up in the order that I read the problem this time. It says 4 for Vanessa, so 4 on the top, we're going to call that Vanessa, and Cody on the bottom, 3. Okay, so I need to make sure that my second ratio, or my second fraction, is also set up the same way with Vanessa's and Cody's information in that order. So if Vanessa jogged 1 mile, okay, if Vanessa jogged 1, how far would Cody have jogged? And that's what we don't know. It's an unknown. You can use any variable you want, but X is one of those common variables that Mr. Gillum likes to use. When I multiply, I cross multiply to solve my proportion. For X equals 3, divide both sides by 4. I know X must equal 3/4. And so these were the kind of the challenging problems, because it was hard to make sense of, or whether it should be 4/3 or 3/4. But if you set your proportion up with the same ratio on both sides, it kind of takes some of that worry out of having the right answer or not. Okay, let's take a look at this last one here. It says a machine worked for 5 hours and used 4 kilowatts. So I'm just going to go ahead and set up a proportion right now. 5 to 4, and that's hours per kilowatt. So my second ratio needs to also be in the form of hours per kilowatt. And so it says the machine used blank of a kilowatt. So it's telling me we don't know how many kilowatts it used for each 1 hour that it used. Okay, so let's go ahead and cross multiply and solve this proportion. 5 times x is 5x, and 4 times 1 is 4. My one-step equation, if I solve it, I know x equals 4/5. So I know that 4/5 of a kilowatt were used each hour that it worked. All right, so we're using proportions to solve these rate problems. In this case, it says a baker used 4 cups of flour to make 5 batches of brownies. Okay, well, let's compare flour to brownies. 4 cups of flour for every 5 batches of brownies. Okay, but we also need to compare it the same way on the other side, flour to brownies, if it really is equivalent. On the other side, it says he used blank of a cup of flour. Okay, well, we don't know how much flour he used for 1 batch of brownies. All right, we've got this nice proportion, and we can solve this equation and find the unknown. Cross multiply. 4 times 1 is 4. 5 times x is 5x, and now I can solve both sides. I see that x must equal 4/5. So he must be able to use 4/5 of a cup each batch of brownies. Again, it says a scientist used 2 gallons of liquid for every 3 hours. So we'll compare gallons to hours, just like that. So 2 gallons to 3 hours. If I compare gallons to hours on one side, though, I also have to compare gallons to hours on the other side of my proportion, assuming that each gallon, it's all equal. So in this case, it says he uses blank of a gallon. Okay, we don't know how much of a gallon he's using for each hour that he works. Well, it doesn't say 1, but each 1 hour that he works. And again, I'm going to cross multiply. 2 times 1 is 2, and 3 times x is 3x. And I can solve my one-step equation now. X equals 2/3. Before I get too carried away, I want to emphasize again, we are cross multiplying because we have a proportion, not because we have a multiplication problem. I know we use the word multiply a lot, and so sometimes students associate cross multiplying with multiplying. Multiplying fractions still stays the same. Reduce, reduce, cross reduce, and multiply straight across. A proportion is an equation that one of the strategies to solve it would be to cross multiply. It has nothing to do with multiplying fractions, okay? This last problem says Luke spent 8 days collecting cans, 8 days, and managed to collect 6 pounds. Okay, so we're going to compare 8 to 6 days to pounds. Okay, and the equivalent ratio, it says he collected blank of a pound each day. So again, we need to have days to pounds again on the second ratio. Blank of a pound, so we don't know how many pounds for each day. And it doesn't say one, but each one day. So 8 times x is 8x. 6 times 1 is 6. Let's go ahead and solve for that unknown. X must equal 3/4. So it looks to me like he collected 3/4 of a pound each day. All right, and again, you can always think about the problem and determine whether or not you feel that it is the correct answer. If I had 3/4 8 times, that would be 24/4. In this case, that would be the same as 6 pounds. Okay, so again, you can always use your logic to see if your answer makes sense, and that'll help as well. So that's it for today. We're using proportions to solve these rate problems.